Dear students, today we will solve the fourth numerical from chapter number 5. This is physics class 9. The question states that a body of mass 20 kg is at rest. A 40 Newton force acts on it for 5 seconds. What is the kinetic energy of the body at the end of this time? So to solve this numerical, since we have to calculate the kinetic energy, and the formula for kinetic energy is 1 over 2 mv square. So we will use that formula, but before that, we will have to calculate the final velocity or the velocity after 5 seconds. For solving this numerical, we write the data here. A body of mass 20 kg, so mass is represented by m, and that is equal to 20 kilogram. And thus mass is at rest, means initial velocity is equal to 0, and a force of 40 Newton acts upon it. Force is represented by capital F, and it is 40 Newton for 5 seconds, and the time t is equal to 5 seconds. 5 seconds. So to calculate final velocity Vf, we will have to first find the acceleration, and with the help of that acceleration, we will find the final velocity. So to calculate acceleration, we know that from Newton's second law of motion, F is equal to ma, and A is equal to F over m. Force divided by mass gives us acceleration. Here force is 40 Newton and the mass is 20 kilogram. So the acceleration will be equal to 2 ms minus 2. Now we will use this acceleration to calculate the final velocity. We know that Vf equals Vi plus At. This is the first equation of motion. And in this equation, we will put the values. For example, since the body was at rest, the initial velocity Vi was 0. And the acceleration we have calculated here, it is 2. And the time was 5 seconds. Here it is, the time is 5 seconds. So 2 multiplied by 5 will give us 10. So it means that the velocity of the body after 5 seconds will be 10 meter per second. Since we have to calculate the kinetic energy, and the formula for the kinetic energy is 1 over 2 and mv square. Now we put the values 1 over 2 and the mass is 20 kilogram. We will put 20 and the velocity is 10 meter per second. Since velocity is squared, so we will square 10. Cancelling 20 by 2 will give us 10, and the square of the 10 will give us 100. 100 multiplied by 10 will give us 1000. So the kinetic energy of the body after 5 seconds will be 1000 joule. Since the units of kinetic energy, potential energy, and the work are joule, so kinetic energy will be represented in joules. Once again, I repeat this solution for the revision. The mass of the object is 20 kg. Initially, it was at rest, so VI was 0. A force of 40 Newton acts upon it, and that force acts for 5 seconds. So we have to calculate kinetic energy, but before the kinetic energy, actually, we have to calculate its final velocity. But for the final velocity, we will need acceleration. Acceleration can be calculated by dividing force with mass, and 40 divided by 20 will give us 2, so acceleration will be 2. And to find the final velocity after 5 seconds, we have the first equation of motion, Vf is equal to Vi plus At. Putting the respective values, we will get Vf is equal to 10 meter per second. And the kinetic energy its formula, and kinetic energy after 5 seconds will be equal to 1 over 2 mv square. You can write here Vf also. It depends upon you whether you write Vf or you may represent it V also. So putting the values and simplifying them, we get that the kinetic energy after 5 seconds will be equal to 1000 joule. Thank you very much for watching this video. See you next lesson.